Hi friends, today we are going to see about the loader design options. Let us see first the difference between the linkage editor and a linking loader. A linking loader, it will perform all the linking and relocating operations including the automatic library search and load the linked program into the memory for execution. All the loading process will be done by the linking loader. It will link and then load into the memory for execution. Whereas linkage editor, it will produce a linked version of the program which is normally written to a file which can be further used for the later execution. We can edit that in the later. For that purpose we can use this linkage editor. When the user is ready to run the linked program, a simple relocating loader can be used for the purpose of loading the program into the memory. The only object code modification necessary is the addition of the actual address. Whatever the actual address is there, it will be added to the relative values within the program. The linkage editor performs the relocation of all the control sections relative to the start of the linked program. All the items that need to be modified at load time have values that will be the relative to the start of the linked program. This means the loading can be accomplished in one pass with no external references for the symbol table. Thus, if a program is to be executed many times without being reassembled, the use of the linkage editor is good. It will reduce the overhead. Next is the dynamic linking. Here, linkage editor, dynamic linking and linking loaders difference is given. The linkage editor, it will perform the linking before the program is being loaded. Before it is loaded for an execution, this process will be done, linking will be done. Whereas linking loaders, it will perform the same operation but at the time of load it will do. Whereas dynamic linking, all the process will be done but it postpones the linking functions until the execution time. Until the execution time, the linking will not be done. The dynamic linking is often used to allow several executing programs to share one copy of the subroutine or a library. For example, a single copy of the standard C library can be loaded into the memory, and then all the current C programs in execution can be linked to this one copy instead of linking a separate copy to each program. In an object-oriented system, dynamic linking is often used for references to the software object, whereas the implementation of the object and the method at the time of program is run. The implementation can be changed at any time without affecting the program. The advantages of dynamic linking is that the subroutines that diagnose errors may never need to be called at all. Whatever the error, it may not be called, and without using the dynamic linking, these subroutines must be loaded and linked every time the program is run. Using the dynamic linking, it will save the space both on the disk and in the memory, and also the time for loading the bigger object program. Everything will be saved. This is the difference between linking loader and linkage editor. Here in linking loader, the object programs are taken to the, it will be linked into the loader. The programs will be taken from the library and then it will be loaded into the memory for the purpose of execution. Whereas in this object programs, it has taken from the linkage editor. We will fetch the programs from the library and keep it in the linkage editor, and it will store in a specific space called linked program. And the relocating loader, it will perform the loading process into the memory for the purpose of execution. Dynamic linking in implementation. A subroutine that is to be dynamically loaded must be called via the operating system request. Instead of executing the JSub instruction, here it uses the load and call service to the OS. The parameter of this request is the symbolic name of the routine to be called, name of the routine which you are going to call. The OS examines its internal tables to determine whether the subroutine is already loaded. If it is loaded, it will leave. If it is not loaded, it will load from the library. Then the control is passed from the OS to the subroutine being called. When the called subroutine completes its processing, it will return again to its caller. The OS then returns the control program that issues the request. After the subroutine is completed, the memory that was allocated will be released. However, often this is not done immediately. If the subroutine is retained in the memory, it can be used by some other programs so that it need not be loaded multiple times. Control can simply pass from the dynamic loader to the called routine directly. This is the implementation example. Here, load and call service request is given, and then here load and call subroutine into the memory. It is done through the memory. Similarly, here the control is passed to the loaded subroutine, whereas here the control is returned to the loader and later it is returned to the user program itself. Similarly, here the called subroutine, this time what it is already present in the loaded. In the space, it is already loaded. Thank you.